Welcome to the Bridges to Success workshop. I'm Jim Fowler. I'm at The Ohio State University in the math department, and Shel Yonker and I are co-leads for the Communication, Outreach, and Engagement subgroup of the Ohio Math Initiative. It's an honor to share with you some of the successes that the Ohio Math Initiative has already had. My goals today are fivefold. I want to introduce the Ohio Mathematics Initiative. I'll talk about the steering committee, its formation, and its early recommendations. I'll take a look at what data is telling us is happening. I'll highlight some of the work that the Ohio Math Initiative and the public institutions in the state of Ohio have already achieved. And I'll talk about Ohio's Gateway Mathematics courses and the new mathematics pathways. So where did the Ohio Mathematics Initiative get started? Well, it all started with a call for change from the institutions themselves. Some of the big concerns were the success rates in mathematics courses, which are unfortunately not as high as we'd like to see them, transferability and innovation, and student success. These are very complicated issues. To get a feeling for just how complicated they are, think about transferability and innovation. From a certain point of view, these two goals are really at odds with each other. Right? In order for transferability, you need to have standardized courses across the state. But for innovation to take place, you've got to have a lot of local autonomy. People have to be free to innovate. So being able to provide an environment that simultaneously accounts for transferability of courses and allows a lot of local autonomy is really a challenge. These things are in tension. In light of these difficult concerns, a statewide mathematics summit was convened on May 8th of 2013. The point of the summit was to discuss and to learn about the dynamics of policies that are impacting mathematics education in Ohio. About 150 math faculty from all 36 of Ohio's public colleges and universities participated, and they gathered for a discussion of the issues facing math education at both state and national levels. Dr. Uri Treisman, professor of math and public affairs, and the founder and executive director of the Charles A. Dana Center at the University of Texas at Austin, he presented as the keynote speaker. During the summit, small group discussions engaged summit participants in sharing thoughts and ideas on how to move the state forward. The summit was facilitated by Dr. Randy Smith, the vice provost for academic programs at The Ohio State University, and Ms. Kathy Chudzinski, professor of biology at Terra State Community College, who are the co-chairs of the Ohio Transfer Module Faculty Subcommittee. As a result of the summit, the Math Steering Committee was formed. The steering committee studied the national trends, the then current initiatives, and available statewide national data. And subsequently, the steering committee made recommendations for math projects in the state of Ohio. The steering committee was comprised of 12 math faculty from Ohio's public institutions of higher education, 5 ex officio members, and Ohio Department of Higher Education staff. In addition, the Charles A. Dana Center at the University of Texas provided expertise and guidance to the committee. Math departments are the real-life Hogwarts, the school of witchcraft and wizardry, because in math departments, students are actually studying the real-life magic that makes our technological world work. And yet for many of our students, mathematics and math departments are less Harry Potter than they are Hunger Games. Math classes feel like a series of pointless procedures to filter folks for the entertainment of elites. And those feelings aren't the students' fault. It's mathematicians' responsibility to make the case for the value of mathematics, it's certainly not pointless, and to assist students on the journey to mastery. It's not a filter, but it's also not happening. Well, one thing that's supported by the data is that way too many first-year students are requiring remediation. The majority of those entering a 2-year college are enrolled in remediation, and a quarter of those entering a 4-year college are enrolled in remediation. Certain subpopulations of students are even more likely to be headed towards remediation. The problem is that remediation slows down students from progressing on their desired plan of study, and ultimately, that can make it less likely for them to be successful in school overall. A broader context for this can be found in the President's Council of Advisors on Science and Technology, the PCAST report from 2012. This was the Engage to Excel report that recognized for the United States to retain its historic preeminence in science and technology would require 1 million additional STEM professionals over the next decade. Where are these STEM professionals going to come from? Well, they're going to come from those who start in STEM but ultimately leave. and lots of students are fitting that mold. For instance, about half the students pursuing a STEM bachelor's degree between 2003 and 2009 had switched from STEM by 2009. In order to help more students to be more successful, we need only stop the initially enthusiastic students from eventually leaving. Remediation wouldn't be bad if it were effective, but it isn't. Very few of those students who participate in remediation actually make it to graduation day. Of the more than half of the students in two-year colleges that are enrolled in remediation, 48% complete that remediation. About a quarter complete the remediation and the associated college-level courses within 2 years, but only 6.4% graduate within 3 years. The situation's not all that much better in the four-year colleges. Sure, fewer students start in remediation. About 57% complete remediation, about 39% complete remediation and the associated college-level courses in 2 years, but only a third graduate within 6 years. That's not success. That's mathematicians failing to provide the support our students need. Things aren't going much better, even for students who start off in college algebra. Of the students who take college algebra, fully 90% of them won't take an engineering Calc 1 course. Of the 90% that don't take the Engineering Calc 1 course, about a third will take business calculus. But virtually no students who pass college algebra will ever even start Calculus 3, a key course for a STEM degree. Ultimately, improvements to instruction, like actively engaging students in Calculus 1, might be a key towards retaining STEM majors. If we can make calculus courses more compelling, maybe folks will stick with STEM. For many students, they'll be studying mathematics for a decade of their life, potentially to terminate their mathematical journey in a course called pre-calculus. Having a student study mathematics for so long only to end their journey in a course called pre-anything is pretty much wrong. Ultimately, mathematics has the best products and some of the worst advertisers. There's math in the coding theory that makes cell phones work, the crypto for online shopping, the spherical trigonometry for naval empires, the Riemannian geometry for GPS navigations. Search engines run on linear algebra, and spam filters run on Bayes' theorem. That something with such diverse and powerful applications still remains a unified field of human inquiry is itself a sort of magic. Mathematicians are responsible for much of the magic of the modern world, but we could be doing a much better job of helping students discover that magic. The great news is that the Ohio Math Initiative is well positioned to make some radical transformations to remedy this situation. So here's some of the work to date. One thing that the Ohio Math Initiative did was to increase departmental flexibility regarding prerequisites and credit hours. We've removed the prescribed prerequisite requirements from gateway courses for acceptance into the transfer module. Now, that sounds a little bit confusing. But practically, what this permits is the creation of co-requisite courses. Instead of students being condemned to prerequisite after prerequisite, students can enroll directly in a college-level course, but if they're underprepared, they could then enroll in a co-requisite course to help them to be successful in that college-level course. This strategy provides flexibility. It provides local autonomy to departments to explore different ways of helping underprepared students to succeed in college-level mathematics as quickly as possible. And this is a great example of the success of the Ohio Math Initiative. Sure, it's a statewide effort, but it's coming alongside local institutions, providing additional flexibility to those local institutions and local autonomy so that they can explore different ways of helping their students to be as successful as possible. It's a great example of how the state of Ohio is operating collectively to help individual institutions and ultimately individuals reach their potential. Another task the Ohio Math Initiative has finished is creating a college-level mathematics course definition. Well, here's the definition. A credit-bearing college-level course in mathematics must use the standards required for high school graduation by the state of Ohio as a basis, and must do at least one of the following: broaden, deepen, or extend the student's learning. Now, this was endorsed in 2014. The idea here is to clarify exactly what a college-level mathematics course is. This is important for a couple reasons. One is because it clarifies the threshold between remedial and college level. A college-level course has to be beyond high school exit standards. Additionally, this definition makes it clear that intermediate algebra is not to be considered a college-level course. And there's even more work that the Ohio Math Initiative has done. The Ohio Math Initiative has also been redesigning the Ohio Transfer Module course criteria. These are the articulation guidelines that make it possible to transfer general education courses and credit between the institutions in the state of Ohio. The big thing here in fall of 2015 was to revise the learning outcomes for college algebra, intro statistics, and quantitative reasoning. Let's dig into this a little bit more. Let's take a look at what those new revised learning outcomes look like. Here's the original text from TMM 001, College Algebra. Functions. Represent functions verbally, numerically, graphically, and algebraically, including linear, quadratic, polynomial, rational, root, radical, power, exponential, logarithmic, and piecewise defined functions. Now take a look at the new text. Here are the revised guidelines. 1. Functions. Successful college algebra students demonstrate a deep understanding of functions, whether they're described verbally, numerically, graphically, or algebraically, both explicitly and implicitly. Students should be proficient working with ... It goes on. Students should be proficient working with the following families of functions. And then it reprises a list that's similar to the list from the original guidelines. The upshot here is that these revised guidelines are now student-centered. And I think it's important that the guidelines ultimately are aligned with the kind of pedagogy that we want to be emphasizing as instructors. We want our classrooms not to be topic-centered or teacher-centered, but ultimately to be learner-centered. And the new guidelines reflect that. They also amplify and expand on some of the tasks that we expect our learners to be able to do. Here there's a new section on analyzing functions, and in that section explains how the student can not only perform some rote processes, but can also articulate the reasons for choosing a particular process. Ultimately, mathematics is not just about computation, but also about communication. And having guidelines that reflect both computation and the communication in mathematics is an important achievement. Additionally, the Ohio Math Initiative has been developing mathematics pathways. What are mathematics pathways? Well, they're aligned with specific groups of majors. Sometimes these are called meta-majors. The idea here is to provide some flexibility for a student who knows in broad strokes what he or she would like to pursue, but isn't exactly sure of their precise plan of study. By having a mathematics pathway that's aligned with a specific group of majors, we're providing flexibility for a student to change their precise plan of study while simultaneously providing some degree of personalization so that those math courses are customized and tailored to that particular student's needs. Now, a math pathway is ultimately mathematics, so it needs to be comprised of challenging mathematics content at the college level, and it should be relevant to the groups of majors. It shouldn't just be math classes for math's sake. It should actually be related to the plan of study that the student ultimately will be pursuing. Here's how the Charles A. Dana Center at the University of Texas at Austin describes it. A mathematics pathway is a math course, or maybe a sequence of courses, taken by both college-ready and underprepared students to meet the requirements of their program of study. A pathway allows students to actively engage with math concepts, to access prior knowledge, and to reflect on new learning. And ultimately, that pathway needs to align with specific fields of study. These math pathways are designed to fulfill the original goals of the steering committee. All right, we want to develop high-quality entry-level courses and pathways. We want to increase student success. We want to make mathematics relevant to all students. And we want to provide students with the appropriate mathematics to successfully support them in their chosen field of study. Mathematics pathways are themselves a pathway to satisfying these goals. Now let's take a look at what these math pathways actually entail. What are the mathematics pathways that the Ohio Mathematics Initiative is actually proposing? The first would be a statistics pathway. This would be comprised of college-level intro stats courses which are designed for students without a calculus background and who don't require college algebra or calculus. This would be part of the general education requirement for majors in fields that could include nursing, nutrition, social work, or an associate's degree in business. The idea here is that the stats pathway is for a student who isn't pursuing college algebra or calculus. That'd be the STEM pathway we'll see in a minute. The second pathway would be a quantitative reasoning pathway. These would be college-level courses designed to emphasize quantitative thinking and problem-solving using quantitative methods. The idea here is that the quantitative reasoning pathway could become part of the general education requirement for majors in fields like communication, criminal justice, fine art, or some degrees in education, like elementary education, history, social studies, and so forth. A common question is, how does the QR pathway differ from the stats pathway? That's a great question. There's certainly some overlap. One way to think about it is that the stats pathway is ultimately more about data coming from the real world. How do you describe the data that you might find in a table or a spreadsheet? While the QR pathway might be emphasizing problem-solving skills or math modeling, where you're trying to mathematize some kind of real-world scenario. But certainly there's going to be some overlap, and I'd absolutely expect some statistics to be discussed in a quantitative reasoning course. The final pathway, the third pathway, is the STEM preparation pathway. And for folks who are teaching in math departments, this might be the pathway that we're most familiar with. It's the usual college-level courses designed for students in math-intensive majors. Examples of courses in the STEM prep pathway might include College Algebra, Pre-Calculus, Trig, Business Calculus, and the Standard Calculus course. This third pathway would satisfy the general education requirement for many of the majors where we already expect students to have taken some of these courses, like business, engineering, physics, chemistry, as well as some degrees in education, like math education or science education. The goal with these pathways is to make math courses more relevant, more interesting for more learners. Right now, a lot of the students who are taking one of these STEM prep courses, College Algebra, Pre-Calculus, well, for them, that might be their terminal math course, the end of a decade of mathematics education. We should absolutely be asking whether those courses, whether College Algebra, Pre-Calculus, or Calculus, are really providing the capstone experience for somebody who spent so much of their life studying mathematics. For too many students, it's just not clear why they're in a College Algebra, or a Pre-Calculus, or a Calculus course. The promise, then, is that this system of mathematics pathways will make it possible for students in Ohio to have more compelling mathematics experiences that are more appropriate, tailored to their specific plan of study, resulting in better math outcomes. Thank you so much for the opportunity to share today. On behalf of Subgroup 3, the Communications subgroup of the Ohio Math Initiative, thank you.